In this presentation, I'm going to go over density. Specifically in this presentation, I'll first go over the parts of density, mass and volume. We'll then talk about the definition of what density is and the comparison of different objects and their densities. And we'll finish up with some calculations of density or involving density. So first, let's talk about the different parts of density. The first part of density is the mass. Now, mass is how much matter is in an object, and we usually measure that in units of grams or a lowercase g representing grams. You use this in chemistry very often. There are other units, but we really stick with grams or, again, abbreviating as a lowercase g often. Also, don't forget for these notes that anything you see which is underlined and bolded, such as how much matter, grams, or that lowercase g, are spots to fill on your guided notes. Mass is directly related to how many atoms and what type of atoms there are in an object. So if I look at this block of wood down here and I represent it as having atoms on the right, this block of wood is really made up of a bunch of different atoms. And really, these are going to be atoms of a certain type. Different atoms do weigh different amounts, but for our purposes, it's okay to think of mass as just how many atoms there are. And we measure mass with a scale or a balance. You can see that tool on the bottom of the screen here. You can use those terms interchangeably. All they are is something that you put an object on the scale and you measure how much it weighs, which is a representation of how much mass an object has. Our second part of density, volume, represents how much space an object takes up. And we typically report this in units of milliliters, or we abbreviate that as lowercase m, uppercase L. And there are, again, many units for volume. You could talk about gallons or liters or even ounces in a way. Ounces is an interesting one. But these are really representations of just how big an object is. And we can measure volume with many different tools. We can do this with a ruler. Indirectly, we'd have to do some math, a graduated cylinder, or through a method called water displacement. You can see this ruler down here. You'll also see this picture of a graduated cylinder, and the method being used here on the bottom right is actually water displacement. Basically, you take an object, you first fill a graduated cylinder up with water so that it will cover the object. You get this initial volume measurement of the water with no object in it, place the object in the graduated cylinder, and see how far that water rises. So, for instance, if this water rises 30 milliliters when you place the object in, the object itself is 30 milliliters large. It takes up 30 milliliters. That's its volume. For solids, we can usually get away with rulers, but not always. There's some irregularly shaped solids that would be difficult to get some kind of volumetric measurement. And we'll use something like a graduated cylinder very often for liquids to measure that volume directly. There are actually markings on the side of the graduated cylinder showing what the volume would be. Now let's talk about density. Since we have the parts, we can put them together. Density, the definition would be the amount of matter within a given space. But using the terms we just learned, density is the amount of mass within a volume. And the units of density are typically given in grams per milliliter. And this should make sense because we're talking about how much mass in grams there are in how much space in milliliters. So let's take this block of wood from before and compare it to a block of steel. The block of balsa wood would have a very low density of 0.475 grams per milliliter. Now, I call this a low density pretty much because it's below 1 gram per milliliter. That's typically what we'd say would be low versus high density. The steel, on the other hand, has a very high density, 7.85 grams per milliliter. Because it's above that 1 gram per milliliter, it would have a higher density. And if we think about holding a piece of balsa wood versus holding a piece of steel, the steel would seem heavier per the space it takes up than something like balsa wood Now, balsa wood, because it has that lower density, its atoms are going to be much more spread out and probably of a lighter type than something like steel, where because it's a high density, the atoms are packed very close together and there are many of them in that space. Now, let's talk about density and how it relates to, say, floating. If I take something like water, which has a density of 1 gram per milliliter, and I put an object in water, if that object has a lower density than water, like balsa wood, it would float. Whereas an object like steel, with a density higher than water, would actually sink. Now, what's interesting is when we look at something like ice. Ice, which is the same chemical as water, it's both H2O, ice actually has a lower density than water. And that is why ice floats on the top of water. Now, let's go into that a little bit further. If we look at, say, the atoms in water, in liquid water, they're flowing kind of all over one another, and they're actually pretty tightly packed. When water freezes, though, into ice, the atoms actually get more spread out. They are locked into place somewhat, but they're more spread out, which makes them less dense than the water. And that's why ice floats, because its atoms are more spread out than those in water. So last, let's talk about how we calculate density. We're going to use 3 different equations, but they're actually all based on the same thing. Our first equation is the simple one. Density equals mass divided by volume. And I can shorten that to say D equals m over v. We would use this equation if we want to find density, but we know mass and volume. And typically, we can measure mass and volume, so this will be the most common equation that we'll use. As an example, let's say we have an object with a mass of 65.1 grams and a volume of 125 milliliters. We want to know what is the density of that object. Well, we'd take our equation, D equals m over v. We'd plug in the 65.1 grams for mass, and we plug in the 125 milliliters for the volume, because we know grams are mass and milliliters are volume. And then we divide the two to get a density of 0.5208. And don't forget those units for density, grams per milliliter. Our second equation is similar. It is volume equals mass divided by density. All we've really done is switch the place of density and volume in this equation. And we can abbreviate that as V equals m over d. We would use this equation if we want to find the volume of something, but we know its density and the mass of the sample that we have. As an example, let's say we know an object has a mass of 22.5 grams and a density of 3.2 grams per milliliter. And we want to know, what is its volume? What is the space that it takes up? Well, we'll use V equals m over d. We will plug in for mass, 22.5 grams, and plug in for density, 3.2 grams per milliliter. We would divide 22.5 by 3.2 and get 7.03 milliliters as our volume. Our last equation would be mass equals density times volume, or shortened, m equals v times d. And we would use this equation if we want to find the mass, but we know the density and the volume. And you'll notice in all these equations, we've set them up so that the thing we're looking for is by itself on one side of the equals sign. And everything else that we know or can measure is on the other side of the equal sign. As our final example, let's say we have an object that has a volume of 45 milliliters and a density of 1.67 grams per milliliter. And I want to know what the mass of this object is. Well, because I know volume and I know density, I'll use my mass equals volume times density equation. I will plug in for volume, 45 milliliters, and I'll plug in for density, 1.67 grams per milliliter. And when I multiply those out, I'll find that my sample has a mass of 75.15. And that's it for this presentation. I hope this helped you understand beginnings of density.